We're going to talk about reactive systems in Java. First, let's take distributed systems. Most software systems today are distributed systems, and distributed systems are hard to design, build, and operate, especially on the scale we need to implement these new modern applications. So what are the similarities? So, still you need to handle failure. We have to know that this is asynchronous communication, which happens a lot in complex distributed applications, and the topology also changes, and the dynamic, and there is a need for the dynamic availability of resources. Can crowd come to the rescue? At massive scale, and hence elasticity is high, we are in a situation where we need to be running more on fewer resources and it becomes a stringent concern. Now, before going into what is reactive streams, the manifesto or the specification which was created in 2013, and to know about reactive programming to start, let's talk about what is a process, what is a thread, and what is a scheduler. A process is an instance of your program and has its own isolated memory space. So it has resources allocated by the OS, including memory and socket. A process is heavyweight and expensive to create. The CPU, but still, the process is not what executes the instruction. It's still the CPU that executes the instructions, and like I said before, not the process itself. Now, what is a thread? Threads share memory allocated to a process. A process can have one or more threads. And finally, what is a scheduler? OS as a scheduler that assigns the thread to the CPU for execution for some time depending on the algorithm. Scheduler determines how long the thread can execute. So for scenario that's a single processor, the time switches among the threads. If there are multiple processors, the scheduler tries to assign one thread for each of the processors. Going to synchronous and asynchronous, the synchronous execution performs tasks sequentially. A process waits for a prior process to complete before proceeding. In asynchronous execution, a process doesn't wait for another process to complete. Blocking versus non-blocking. The blocking operation is one that does not return control to the caller until it has been completed. For example, a blocking read operation on a file or network socket will wait until data is made available before returning. A non-blocking operation is one that returns immediately without waiting for the operation to complete. Synchronous blocking. Synchronous blocking operations wait for the completion of a task before proceeding to the next one. During this way, the calling process or thread is effectively halted and the resource is wasted sometimes when the scale increases. It's at massive scale. Example, reading from a file where the process waits until the data is read before continuing with the next instruction. What are synchronous non-blocking? Synchronous non-blocking operations return control to the caller immediately if the operation would block, allowing the caller to perform other tasks or check back at a later time. Example, attempting to reach from a non-blocking socket which runs immediately if no data is available, letting the program continue other operations. What is What is asynchronous blocking? Asynchronous blocking operations initiate a task and allow the caller to proceed with other operations. However, the caller is eventually blocked when it needs the result of the initiated task. Example, initiating a file read operation, a file read operation, and continue with other tasks, but blocking later when the data is needed and the read operation is not yet complete. Asynchronous non-blocking. Asynchronous non-blocking operations allow tasks to be initiated and completed without ever blocking the caller. Completion is usually handled via callbacks, events, or polling. For example, using a asynchronous API to read from a file or a network socket where a callback function is invoked once the read operation completes. Reactive stream specification. Let's now talk about the reactive stream specification. As applications get complex, like what we saw in the case of asynchronous non-blocking I/O, the users expect notifications more frequently than before as applications get complex. The usual request response communication doesn't work anymore. Reactive streams is a standard for asynchronous stream processing with non blocking backbrush. So reactive programming is a declarative programming paradigm that is based on the idea of asynchronous event processing and data streams. Object-oriented programming languages like Java does not have the tools to simplify the non-blocking asynchronous call. This is what reactive programming helps to achieve. It is based on the observer pattern, observe and react to a stream of messages. So let's take this example. We have an end publisher, a set of processors which act as a subscriber and a publisher, and end subscriber. Now, the subscriber can subscribe to the publisher, and then it can also act as a publisher for uh, many of its other actors which are subscribed to it. So there can be n number of processors or this combination of subscriber and publisher which does this operation. Now going to this publisher subscriber, so so if we see, we have the objects subscriber, publisher, and the subscription. Subscriber wants updates from the publisher. Uses the subscribe method on the publisher, passing the subscriber instance. Publisher accepts the request and uses the onSubscribe method on the subscriber to hand over the subscription instance to the subscriber. At this moment, all transactions happen to the subscription object. The subscriber uses the request method of the subscription to request for items. The publisher promptly can invoke the onNext method of the subscriber to provide items and then for onComplete to tell that it has no more information to be shared. Thank you.